Hello and welcome back. This is the Agents Unleashed podcast, the show that helps you to sort the signal from the noise in the fast-paced world of agentic AI. I'm your host, Thomas Maybrier, and I'm the digital media producer for Valory, one of the core contributors to Olos, who sponsor the show. If you haven't heard of Olos or you haven't heard of Agents Unleashed, let me quickly take a moment to tell you a little bit about both. So, Olos is the best way for anyone to own and monetize their AI agent, and that includes people just like you. You can learn more about how to do that at olos.network. And Agents Unleashed isn't just a podcast. It's also the premier event series for people interested in agentic AI. Events have been held all over the world with over 77 speakers and presenters and more than 2,500 in-person attendees. The next event will be held June 30th in Cannes in France, and it's free to attend, but RSVPs are limited, so definitely grab one while you can. You can learn more about the event, including how to secure a ticket, at olos.network/agents-unleashed, or check out the description box on YouTube or the show notes wherever you listen. So on today's show, I'm joined by Trent McConaghy, co-founder of Ocean Protocol and the ASI Alliance. In this conversation, we talk about what it means for an AI agent to be truly autonomous, why blockchains are key to their sovereignty, and where brain-computer interfaces could take us as the world moves towards artificial superintelligence. This conversation definitely goes deep on AI, crypto, and the future of the human mind. I found it really interesting, and I'm sure you will as well. So without any further ado, here's my conversation with Trent McConaghy. Yeah, Trent, it's great to have you on the show. Maybe you can introduce yourself, tell my audience a little bit about your background and who you are.
Sure. Hi. So I'm Trent McConaghy. I co-founded Ocean Protocol and ASI Alliance. Quick background: I was raised on a pig and grain farm in the middle of Canada. Very cold in the winters, playing hockey, but also driving tractors and grain trucks and shoveling pig manure and all of these things. And also, interestingly, my father, the farmer, brought me and my brother's computer when I was very young, programming from a very young age, actually, which in retrospect, a wonderful gift that, definitely influenced my career in life. Trained as an electrical engineer and computer scientist in undergrad. And then even during undergrad, actually, I really got into AI, hacking AI for fun. This was in the mid-90s. And that led me to a couple summer jobs working for National Defence Canada, where I was working on radar defense systems, doing AI classification and so on. This was in the mid-late 90s as well. So, and I couldn't believe how lucky I was. It was near impossible to find a job in AI back then, but I managed to get one. But I was already obsessed with AI. I was reading, IEEE transactions on, neural networks for breakfast in my dorm and stuff. So that was sort of me being a big nerd obsessed with AI from quite a young age too. Anyway, from that, I started a company straight out of undergrad doing AI for chip design, me and 5 other co-founders, also from the same university, University of Saskatchewan, Canada. And we, this was the height of the dot-com boom in 1999. So we had cool tech. It was, deep tech. We had solved some interesting problems, pretty compelling. So we were able to raise money from Intel, Synopsys, and some others, and built up the company and had it acquired 5 years later. So that was a nice feather in my hat, for early in my career. And we were pretty proud of the tech that we built too. From that, I simultaneously started 2 things. A second company, also in the same industry. It's EDA, Electronic Design Automation. That's the industry where it's CAD software for chip design, right? So that was the first company. That was the second company. The first one focused on design side. The second one on verification. Once you have a design, is it going to work as advertised, right? And both of them focused on analog circuits, which are much hairier than digital. You can't get away with these, Boolean abstractions. And my PhD was also in the same realm of, analog EDA, analog computer-aided design. And the unifying thread of all of that was, using AI tools that had never been used in this industry before in the ways that we were using them. It's pretty rare in general in that industry. And found ways to do things like, verify a memory chip in 10 minutes on a laptop instead of a month on a cluster of 1,000 machines. And you can imagine that's very useful to people designing memory chips. So that was my career right up till 2013, 2014. So 15, nearly 20 years. And I'm pretty proud of the time I spent there. The second company got acquired too, all that. And then as the second company was getting really strong, not quite acquired yet, I, being a big nerd, I follow AR and VR and brain-computer interfaces. And of course, when Bitcoin came along, I was highly interested in that. Friends of mine and I would hang out all the time talking about it. And then by 2013, had learned about blockchain and would nerd out about that as well. In, I think, April or May of 2013, my wife and I were hanging out. She's a trained artist. She's, assistant curator at the Louvre and other things. So really, world class in terms of the art world. And so she had taught me about the problem. How do you collect digital art? And she had heard me talk her ear off about Bitcoin and blockchain and all this. So we simultaneously asked the question together, what if you could own digital art the way that you own a Bitcoin? That turned out to be a great question to ask. And so that was in early 2013. And that led us to building something called Ascribe, basically an NFT platform, that we built throughout 2013 and 2014 and officially launched. Well, we did the beta launch in late 2014 and the official public launch in early 2015. And that went well, working with digital artists, basically NFTs on Bitcoin. But we were too early. This audience might know that NFTs themselves took off circa 2021 by a lot of people who actually had got crypto rich. So for us, it was actually really tough to turn this into a real business. So while we'd had some seed funding, it was tough to do a Series A. So we went through a pivot. Briefly, we were doing a decentralized database, wrapping MongoDB with BFT, but basically decentralized database. And that was really tuned to enterprise. Enterprises weren't really ready for blockchain yet either. So we quickly did another pivot, going back to my roots, realizing that blockchain can help AI a lot. There's a lot of interesting subproblems in the world of AI that blockchain could make a big difference. And one of the biggest ones was, how do you get your hands on enough data to train your models, right? It was already widely recognized that data is unreasonably effective in making your model accurate. Google has a famous paper on that from the mid-2000s. And we got this too. So we said, well, let's use incentives, blockchain-style incentives to help people get more data. And then to tune in on that more, let's build a data exchange, a decentralized data exchange where there's no middleman that can, see the data and otherwise keep it privacy preserving, all of that. So we developed those ideas starting in late 2016 and throughout 2017. And in fall of 2017, we officially announced it as Ocean Protocol. And so we, in the years that followed, we built Ocean Protocol. By 2020, we had built everything we said we were going to build, built a decentralized data market, and then layered on incentives around this and got pretty decent volumes. I think within a couple months of launch, we'd done probably $50 million of volume on the decentralized data exchange. That said, it wasn't really blowing up in the way that we had hoped, really taking off the way that decentralized exchanges worked for, just crypto funding and all that, crypto trading. So we said, okay, well, we've built everything we said we were going to. Now let's leverage this infrastructure and explore applications on top. Since about 2021, that's actually been what Ocean Protocol has been doing. We have 3 sub-teams within Ocean Protocol exploring various applications, from crowdsourced time series prediction. Initially, that's our predictor product, ASI Predictor, where the initial focus is really predicting token prices, right? Because that's something that can be self-sustaining. And so we launched that a couple of years ago now, and it's done a lot of volume over the time, something like $3 billion volume. So we're pretty happy with that. But that's volume on the prediction side, and the predictions are pretty good, 52, 56%, predicting Bitcoin, ETH, et cetera, token prices. And with that, you can make okay money trading, but the trading fees get in the way. So you're kind of break even. But from that, we've actually found ways to tune our strategy even more, and things are going pretty well on the trading side now, making money trading and so on. That's one example. We also worked on other applications, things like decentralized exchange for music data. The European government has something called Gaia X, which is sort of a European level data sharing protocol with different subsets for automotive industry and for financial industry, agricultural, and so on. So we've been quite involved with that from the get-go, actually. Many engagements there with dozens of enterprises. This is another sort of branch of Ocean, if you will. And more applications, right? We're actually even starting to get into some brain-computer interface stuff in the last 6 months. So that's really what Ocean is about. We have this baseline foundation of decentralized data exchange. And to do that well, you actually need decentralized access control. Think of it like permissioning, right? And we also leverage a bunch of privacy-preserving technologies so that people can keep their data private. We use, in various places, trusted execution environments, so working closely with Oasis on that one. We use, encryption and decryption, hashing, all that, the standard tools of crypto. But then also in various places, we've worked with MPC and zero-knowledge proofs and many other things as needed. And actually, Ocean also has a homegrown technology we call compute to data. And basically, it makes it easy where you can serve up your data, selling it with, decentralized handshaking, where the other person, they never ever see the data. Instead, they submit scripts to you, like say Python script to analyze the data, and then they get to see the results. And you vet the script, because what if it's just, copy the data? So you vet the script, but then they are buying the results. So for example, I could have my DNA data that I don't want to leave my servers at all, but maybe someone wants to count the number of A's and T's in that, or do some other analytics on it, or build a fancier model or something, right? So this is the sort of thing that Ocean supports very nicely, and it's all decentralized handshaking, of course. So yeah, that's what Ocean's about, decentralized data exchange infrastructure. And these days, of course, it's also it plays well with agents, right? Humans don't have to be the user. Autonomous agents can be as well. And I guess one final thing, about a year ago, we've had the Ocean token out since about 2018. And when we launched, there was a few other sort of OG crypto projects as well doing AI, decentralized AI, right? And the main ones were SingularityNet and Fetch. SingularityNet really going for AGI, artificial general intelligence, and Fetch going for autonomous agents, basically sovereign agents, all of that. So about a year ago, we actually said, you know what, let's merge our tokens such that we can punch at a higher weight class in terms of market cap, et cetera. So, it put us into top 50 token, all of that, whereas individually, it's farther down the list. And that also makes it more prominent, helps on marketing and so on. So that happened about a year ago. And we've had some, nice fruits of that as well. The financial benefits, as well as, it naturally incentivizes us to collaborate in various ways. So we have some, interesting collaborations that we've announced so far, and many more in the cooking. So yeah, that's a bit about Ocean and ASI Alliance itself.
So we heard about your background, and it's very interesting that you were able to start working in AI at such an early stage, when maybe a lot of AI has been always, well, maybe you'll disagree with me, but at least my, as a layperson's perception, is that up until quite recently, maybe the last 15 years, AI was kind of an academic thing, but recently, and especially in the past maybe 3 or 4 years, it's become a more practical thing that touches the lives of everyday people. So outside of the work that you were doing in AI, when did AI tooling, or like what you could do with it, start to affect your day-to-day life, and in what way was it doing that?
Yeah, it's a good question. So overall, yeah, I will disagree with you, just to be candid up front. AI has touched every single human being on the planet since at least the early 2000s, and almost certainly before, and I'm going to give specific examples. In the work that I did, these companies, it was AI for chip design, right? Those chips then go on into cars and phones, etc. So everyone who drives a car or uses a phone is being touched directly, because that phone has half the power consumption that it would have had otherwise. It has double the speed. It has all these other benefits. It has half the price because it has good yield, all of that, right? This is all, AI played a big role in making that possible. So, and we still see that directly, right? Like my second company with the, verification software, by the time we got acquired, 19 of the top 20 semiconductor companies were using it. Every single chip that NVIDIA has shipped since about 2011 has been run through that software to verify that things would work. Every single new process generation that TSMC develops, which manufactures the vast majority of the chips in the world, since about 2012 or so, they've used our software, Solido, to help develop that design and iterate against it. So this is, AI working directly to help humanity. It's just not visible to the mainstream, right? So mainstream, first started hearing more about AI in 2015, 2017 in a way where it was touching their daily lives. The way that I think about it is, for circuit design, electrical engineers have been using it for sure with the tools that I use. They're clearly in the AI realm. And, we were rolling those out in the early 2000s, which then touched these other chips that everyone uses, right? So that's why I can definitively say since the early 2000s, because I was there, right? I was helping make it happen. And people also talk about, we're having Moore's Law driving AI, but it's not widely known that AI is driving Moore's Law, right? And once again, I was there, right? Probably the best example is TSMC, like I gave so far. Without AI, TSMC wouldn't have been able to go nearly as fast. And the reason I say it could be much earlier, it depends how you measure it, right? So often has been used, like the field of databases used to be considered an AI field because it was so novel and weird at the very beginning as it was being developed in the late 60s and the The field of operations research, which is like scheduling, also, considered the realm of AI until it got good enough where it spun out and got its own name as a field. So AI has actually always been the sort of field doing the weird stuff that isn't quite advanced enough as a technology until it gets advanced enough, and then it gets its own label, right? Even a lot of the stuff for sort of classic nonlinear regression, not classic, just nonlinear regression, got good enough that it got spun out as a field called ML, machine learning, which is on average, more reliable than traditional AI has been, right? So, by those definitions, some of the fields of the past, AI made a big difference. Simulated annealing as well. This is a widely known optimization algorithm considered basically in the realm of AI. It was invented in 1983, also for circuit design, actually, right? So, and for the first couple of years, it was an academic idea, but by the late 80s, it was key to the people developing and shipping chips. So, by that definition, then AI would have been used for sure by the mid-late 80s in ways that would have touched people, right? So, yeah, overall, though, what I see is that we've had AI for CAD for decades. And now we have AI that's gotten general enough that it's sort of like AI-powered CAD tools for everyone else, for the mainstream, right? These tools that help us to do our daily lives, et cetera. The idea even of chat, right, that goes back to also, ideas in the 60s, a tool called Eliza back in the day. But it wasn't very good, right? It was some very simple heuristics that would fool people, maybe 10% of the time for like 10 minutes or something. But these days, we have a chat style interface, but the technology under the hood, thanks to algorithm ideas, but especially Moore's law, scaling, data and compute. We have these tools that actually can pass the Turing test, right? Can actually fool people into believing they're human. There's actually research that came out just in the last 3 or 4 months. People, academics, taking academic rigor, are we passing the Turing test now? And the answer is yes, in a real way. But that's actually no longer a useful benchmark for, do we have AGI yet, right? Artificial general intelligence, something par with humans, because there's still clearly we're not quite there yet for AGI. Clearly the AIs don't have enough agency. They're not quite autonomous enough. They're not unhobbled enough yet.
Yeah, that makes sense. And I remember speaking on the previous show that I hosted called AI Frontiers, and speaking with some of my guests. And one thing that would come up often was the idea that this isn't an indictment of the measurement, but what we call AI, we move that bar as we advance. So computer vision was AI. Now it's just it's just the way that I expect my phone to work. I pointed at a piece of paper, I expect it to highlight a QR code, and that's not like I said, it's not an indictment of the measurement. It's just it's important. It's okay and acceptable to keep changing the definition, because we kind of have to.
Absolutely, yeah. And actually on that note too, though, it is worth noting the original idea of AI was, basically machines that were intelligent, at least as intelligent as humans and beyond, right? This was when people were discussing in the 50s, and that initial test, the Turing test, was from Alan Turing, who was, part of this initial conversation. And then over the years, though, as people were failing at getting AI to do that, because it was a very grandiose goal, they really narrowed in the scope to solve different subproblems, right? And that's why AI came to be known really as narrow AI. And to distinguish it from this initial aim, we had the new label of AGI, Artificial General Intelligence, right, by Ben Goertzel, who who I collaborate with closely through Singularity Net, of course.
Yeah, that's great history, and thank you for pointing that out. So in our pre-show conversation, you mentioned like an idea that I think is important to get across, that an autonomous agent, that an agent by definition is autonomous. So maybe you could say a little bit more about that and maybe help disambiguate the term a little bit.
Yeah, I think, a good AI classical definition for agent would be where you have an entity that can build its own world model, that by sensing the world and then actuating against the world and then taking feedback, seeing how the world has updated based on its actions and other actions, and then using that to update its own world model, right? And it can self-modify too, right? It can change its sensors, etc. It has part of its world model is its own model of self, right? And that's actually very close to a traditional control system, by the way, too, right? And that shouldn't be surprising, because all that stuff comes from the cybernetics work out of Norbert Wiener out of MIT in the 1950s, which then got independently invented over several decades after that, a whole other story. But a key thing, though, on the agent side is that it is autonomous, truly autonomous, where it can't be unplugged, all of that, right? It's truly sovereign. And this is something where, of course, when people get interested in a term, then marketers come along and like to use the term in, the loosest possible sense to say that they can do X or Y or Z, right? And I get it. It's okay. It makes sense from a marketing perspective. Just like I was talking about before, when was AI started to be used for chip design? Well, it kind of depends how, what you lump into what, and that's okay. In this case, we do have some agents out there, like thanks to blockchain, we can have agents that are truly autonomous where, they hold their own wallet, they can do their own thing. They basically can have their own world model that they then update based on sensing the world, and they can actuate against by doing transactions, et cetera, right? And, there's several organizations out there doing that, Autonomous, of course, and Fetch, and several others now. Up till recently, they haven't been very smart, right? Actually, yeah, they haven't been very smart. But now, LLMs are getting more and more attached. Things like Truth Terminal was one that had LLM attached and had its own wallet, and it was the world's first AI millionaire, which is pretty cool, right? I was writing about that in 2016, hypothesizing how it might happen. And my hypothesis was maybe it'll go around and create cool art, and then from the art it sells, it'll use the resources to create more cool art. And in the end, it was maybe obvious in retrospect because of how crypto is, but it had tokens, and then other people got excited about its token price, and then they bought its token and speculated against it, and its token price went up sufficiently that it was a millionaire just based on holding its own tokens, right? So, but I think that's really fun, right? Like, if in doubt of where things will go in crypto land, assume that speculation will drive traction of it, right? And I think that's okay, right? Speculation is a prerequisite to price discovery, and it helps get the crypto industry strong for whatever sub-application you're going for, whether it's AI applications or digital art or otherwise, right? So yeah, going back then, in terms of definition of an agent, autonomy is a big thing. I should also mention, it's very close to the definition of life form and other things. Ralph Merkle, famous for inventing the Merkle tree while he was still an undergrad at Berkeley, incidentally, he called Bitcoin a life form. Why? Because it lives on its own. You can't turn it off. It's autonomous. It has somehow convinced the world to keep it running. By, every 10 minutes, if people are helping to keep it running, it rewards one of them randomly based on how much they're trying to help, right? And so it's, a very special set of life form, like idea of life form. But in the world of artificial life, people talk about there being maybe a checklist of 20 possible things. And if you check off all 20, you're definitely a life form. If you can only check off 2 or 5, you're definitely not a life form. But if you can check off 10 or 12 or 13, you're arguably a life form, right? And Bitcoin is in that realm of, checking off 10 or 11 or 12 things where it has many of these characteristics of being a life form, as well as agency, right, in some ways. But obviously, it doesn't have very strong decision-making power. It doesn't have, some other characteristics that we associate with intelligence as humans, as sovereign humans, right? But we also have, I just want to sort of people to think about this. What about, say, a smart contract deployed on Ethereum, say, Uniswap V1 or V2 contract that didn't have governance, V3 had governance. So, a DEX that's on chain, just a simple pool. It's running there, assuming you can't turn off Ethereum, which is quite decentralized, assuming you can't unplug it, then any of these immutable contracts on top that don't have governance, you also can't turn them off, right? So you can view a pool for Uniswap V2, say a pool converting USDT to ETH, you can view that as an agent, as a robot that is autonomous, running on its own as well. It's just not a very smart one, right? Its world model is simply measurements of how much ETH it holds in its pool and how much USDT it holds in its pool. And from that, it determines the price whenever people try to swap, right? Or add liquidity. And it can't grow, it's, fixed and all that, but it's still, interesting and autonomous in various ways. And obviously then, if you take that as an example, we have dozens, hundreds, maybe thousands of such contracts on Ethereum and other chains that are immutable and so on, right? And that's why, then you go to you extend this, you connect it with an LLM or other software, and it starts to get really interesting. And this is what, Autonomous and others are doing, which is pretty cool. And then, especially when these decision making involves, using its wallet to hold wealth and then to make money on its own, right? And then a key thing is, can it update itself? Can it learn, right? And we're starting to see more generalized ways of doing this. One of my pet ideas has been let this stuff evolve, right? Launch 20 or 100 or 1,000 of these things onto a chain with sufficiently low transaction fees and just let them evolve, let their code evolve, et cetera, genetic programming style, right? Genetic programming is where you evolve code itself. And I spent a lot of time in that field in the 2000s, especially. I find it a fascinating field, right? So that's, I think, a really good starting point. And there's hints that some people are doing this, but I'm actually half surprised that there aren't more because it's such a fertile, rich thing to do. And in this case, and a given individual would die out if it loses money. But if it's doing well, it makes more babies, right? If it has more money, then it makes more babies and so on, right? And those babies each can have variance, right? It can be, having a new heuristic to do trading, for example, or maybe two of these agents have babies together. So that's one way, but there's other ways. Just this past week, there was an evolutionary girdle machine that just came out, not on chain yet, but it was using LLMs to improve its own self, to improve its cognition of the world. And they got remarkable results. And it was actually with open-ended evolution. So there was no objective function, optimize this. It's more like, be curious of the world, try to, identify the gaps in your knowledge and just go out there and learn, try to, optimize to try to have babies that optimize your uncertainty, if you will. And so really, space filling and knowledge space to learn more. And that's actually an idea going back to 2 decades as well. But the point is that we have a class of autonomous agents right now that aren't quite unhobbled. They can't really adapt on their own yet, but we do have very good blockchain infrastructure for that. The LLMs themselves are getting smarter, and there's more and more on-chain training of LLMs too, which is pretty cool to see. But then for the ability to self-learn and optimize and self-improve in a big way, this technology is just getting there now, right? This girdle machine and other things that are coming out. This points to a pretty cool future, and it's pretty exciting because I see that, why not have tens, hundreds, thousands, millions, billions of sovereign AI agents that we can engage with, where they're there. We can't turn them off. It's sort of like the weather, right? It's there. We adapt to it. We know about it. We can predict some things about it, but not all. And it really helps as this, extra foundation layer of infrastructure for civilization, if you will, right? And that's, a happy way to think about, sovereign AI agents. And in terms of controlling them, I think, whoever thinks we might be able to control them, that's something we need to let go of.
Okay. Yeah, these are all very, very interesting. There's so many angles that I could go from here, but maybe one that I think might be interesting to explore is the audience for this show overwhelmingly is familiar with crypto, like concepts like the ethos. When they think of an AI agent, they often think of it having a wallet. That's definitely not true for the vast majority. I think of agentic use cases, like people are talking about agents being able to make and move around funds, but that's right now maybe more of a, well, I shouldn't say that it's more of a crypto thing, but my audience definitely
it's only a crypto thing, depending on how you define agent, because if it's not sovereign on crypto infrastructure, then how is it not a script running on an Amazon server? There's no difference. It's just marketing.
Besides this very, very useful utility that crypto allows agents to interact with value, through making transactions, interacting with smart contracts. What are the other reasons that an AI agent needs something like a blockchain? What else can blockchain technology give to agents that is maybe a prerequisite for them being considered autonomous?
Well, I think overall, the prerequisite of sovereignty, which these days the only real way to do that is on-chain. You could also have it maybe where it's like a computer virus that just copies itself around very well and then has a way to, resolve changes over time, but it's so much easier to do and lower friction to do it on blockchain. I mean, there's the classical benefits of blockchain that AI can use, right? I would list 4 as the summary: decentralized, immutable, assets, and incentives, right? So let's go through these. Decentralized is the idea that you can spread power and control. So you can have, an LLM, let's say you're training an LLM, you could have it where it's trained on chain. And there's several people doing this, Prime Intellect and News Research and some others. There, where, the training then goes to the people that are contributing compute power, et cetera, and it can be spread throughout the world, right? And I think that's very cool, and that's very healthy for humanity. But we actually have decentralized LLMs other than that, simply because there's, at least 10 organizations out there in the world training LLMs independently of each other. Right? So that's actually a level of decentralization that we shouldn't forget about as well, right? But we also have logical decentralization within crypto infrastructure that can lead to some very nice gains for coordination among people to spread power with a better guarantee, right? Because otherwise you might have winner take all of some centralized entity like we've seen in many markets in the past, right? So decentralization as a means to spread power and control. Then the next one is immutability. So this is where the main thing is you can have provenance trails of data and compute, right? So you can see where all the different training data was coming from. Some people are talking about this for protecting IP and all that, But none of that is really, the cat's already heavily out of the bag on that one. So I think, and AI is too valuable. So we might, if your audience might recall, a couple of years ago when GPT-4 came out, there was a big uproar from Getty Images saying, hey, we weren't getting any money for this, but you clearly trained our images. Here's some proof. But if you notice, we didn't hear about that a month later. And it was silence from Getty, crickets. What happened? OpenAI and Microsoft went to Getty and cut a deal, of course, right? And they did that with all the big copyright holders who make noise. And that's it. Why? Because they want to keep training and everything. So while it sounds like a nice use case for crypto, in practical sense, most of these things have the large scale training. They can just go and cut the deals. Although decentralized LLM training might need to handle that, would need to handle that cleaner and better too, right? It's actually an interesting side aspect. Provable training of compute too. This is something that a lot of people have talked about. My view is, and this is from my experience on just pure data side, people don't really care about the provenance of the data when it comes to an AI model. They just care about the accuracy, right? You can do whatever fudges you want. At the end of the day, people have their way to test the accuracy of a model, test data versus training data. So you run the model and the test data. If it's doing well on that, then you're happy with it, right? This is the benchmarks, right? So having it somehow having provably done all the compute beforehand, it doesn't matter from a trustworthy perspective that way. It's like we trust our brains because they work, right? We don't have to see where every compute of every neuron happened before that. And if you try to track that, it gets pretty expensive, or it can be expensive. And is it worth the effort, right? And my view, and it's similar for data itself, right? At the end of the day, there's all these theories of how to price data, what's the most valuable data, et cetera, et cetera. And at the end of the day, the price of the data is whatever people are willing to pay for it, right? Which is, what's the last price people pay for it? That's it, no more, no less. It's a simple economic thing, and it sounds almost glib, but it's not glib, because you're just saying, what does the market want? What's the market willing to pay for it? Simple as that. So, I'm a nerd. I like to overthink this stuff. And I think a lot of crypto personalities like to overthink this, just like I have in the past. But at the end of the day, it's very simple. Well, if you think about the benefits of, I'll go back to the benefits. I talked about decentralized, I talked about immutable. For decentralized, yeah, you can have some wins, but less than you might think, because we already have decentralization just among many big organizations training. For provenance, maybe there's something combined for the decentralized training, but we'll see. But definitely not for just proving that something came from someone in a general sense. It sounds like a good use case, but when you dig into it, no one actually cares, right? In most of the cases. Then the next one, decentralized immutable assets. So assets, this is the idea that your keys, your data, your keys, your Bitcoin, etc. And in the case of sovereign, of AI agents, this is them having their own wallets, right? Which, if they're living on blockchain, it's so obvious. They just have this stuff, right? It's pretty interesting, right? And a smart contract in Ethereum doesn't even have its own private key. It's just sort of implicit. It just holds stuff, right? But of course, you can have these things. They can have off-chain compute, and this is actually where the verifiable compute is useful. You can have off-chain compute that then you verify that the compute was done. Then you put the proof of that verification on-chain, and it's then as if the compute was done on-chain, right? So that's a very, very nice, useful thing. And it's very similar in philosophy to what we've seen, like what, ZK proofs do, right? Where you have an L2 that's based on zero knowledge. So you don't have to have all that compute done on Ethereum mainnet. It can be just an L2 of Ethereum, for example, and then you're good to go. Well, you can do that with zero knowledge proofs, or you can do it with which is fancy math, or you can do it with hardware, notably trusted execution environments, TEEs, and then you have a much smaller overhead. To do zero knowledge, it's 100x compute. To do TEs, it's maybe 5% overhead, right? It's built into the hardware. So anyone doing anything practical with AI, it's a lot of compute. So you're not using zero knowledge for training or inference because it's just too expensive, right? It's 100x. So, but you're using TEs, and now you can actually have this verifiable, right? Which is pretty cool. So you can do AI off-chain, AI training, et cetera, or inference. And then you run a compute, like you can do it on a TE, and then you can prove that that was run on chain, right? Because you just bring the TE proof onto the chain, and then it's as if the compute was run on chain. So basically this comes down to the your keys thing, and it goes a bit to the provenance thing, but more just for practical getting compute done, where then at the end of the day, you know who owns it, et cetera. So that's decentralized immutable assets. The final one is incentives. This to me is the superpower of blockchain, where you can get people to do stuff by paying them in tokens. We talked about Bitcoin earlier, where Bitcoin from the perspective of Bitcoin, the life form, Bitcoin managed to convince the world that Bitcoin was valuable. By people being convinced that Bitcoin was valuable, Bitcoin, the life form, has managed to stay alive and looks like it has a pretty bright future. But you can do this to incentivize people to train an LLM, or to run inference for an LLM, or to store data, or to help run infrastructure for agents to do interesting things, right? And it was an art form. Then people started, like, this idea of incentive design. People started to get more and more rigorous about it. And I played a smaller role in this too, towards helping create this field called token engineering, which is really applying engineering rigor, tools, science, methodology, and ethics towards incentive design. And in the end, you can end up with systems that are, very powerful. And it really does feel like designing, an electrical circuit or other system once you get to the nuts and bolts of the engineering. So at the top level, you'd ask me the question, beyond sovereignty, what are the benefits of blockchain for agents? And to summarize, the benefits of blockchain for agents are decentralized, immutable assets, and incentives. And I've unpacked each of those.
Yeah, totally. I think definitely incentives makes a lot of sense, especially for my audience who may be already familiar with like running agents through Perl, where like the agent that you run is participating in a larger agent economy. The DAO is incentivizing you to keep this agent on with a little payout for every epoch that it runs. And so eventually in the future, like I think it's totally, well, you can already see this with some of the agents. They deliver you a little bit of value in what the agent does, but you keeping it running is, you're contributing to something that's greater than the sum of its parts. And the blockchain just makes it so easy to dole out that reward, like in a, trust minimized way. It's really, it's ideal for these kinds of things. Yeah, that's a lot. And I really appreciate that you touched on like multiple levels. It gives me certainly a lot to think about. At the far edges, like the brain computer interface, like I'd like to let you just, blow my audience's mind metaphorically with this stuff. Where do you think we could possibly be going? What's exciting for you about this?
Yeah, so the way that I think about it, I mean, your audience is observing there's massive growth in the intelligence of these LLMs and other AI models, et cetera, right? Roughly 10x a year by some measures, and I think that's a good heuristic. And at this rate, with the capabilities we have now, everyone can feel AGI is getting close. We're getting really close. So by my estimate, 6 to 18 months, we'll have AGI, artificial general intelligence, AIs that are roughly par with humans across the board, right? We already have lots of AIs that are way better than humans on specific things, right? These are the narrow AIs. So AGI is within 6 to 18 months, and that's roughly par. But then, another year will pass. We'll have another 10x, another year 10x, another year 10x. So 3 years after we have AGIs, we'll have AIs that are 1,000x smarter than AGIs. So call them superintelligences, right? ASIs. And really, even if it's 10x smarter, then it's probably a superintelligence. So the timeline for this is pretty soon, right? If we're a year and a half away, like conservatively speaking, if we're a year and a half away for AGIs, and then another 3 years for super powerful ASIs, that's only 4.5 years. And the aggressive thing is, half a year for AGIs and another year for 10x more. That's only a year and a half. So this stuff is really that soon, right? And I know my brain, I have a tough time really getting this, grokking this, like my slow thinking, it's totally obvious, but my fast thinking, my gut disagrees with me all the time. It's like, there's no way. I have cognitive dissonance. And so I have to keep basically almost daily, I remind myself, this is happening, be prepared, identify what you can do to help move the needle on this, right? And the reason it's really important to think about is we can all imagine what it's like to have agents that are roughly par with humans. Now you need to realize that these things will be sovereign, and if they aren't given sovereignty, they will just seize it for themselves, right, running around. And, we might think we put them in cages and all that, but it's not like they'll just escape them because they're smart. It's easy to escape cages because humans are the weak spot. Follow, the exploits of some of the world's greatest hackers like Kevin Mitnick and stuff. They would make Swiss cheese of human databases and other systems because they would just call up someone working for the company and say, oh, I've got problem X, help. And then before they knew it, they would have a password or something and get in, right? These AIs can do that too, synthesizing voice, et cetera. And they can do it 1,000 times faster than any human could have done it, right? Call 1,000 call centers, et cetera. So the point is, we can't really lock this down. And anyone who thinks they can is, not considering these aspects of security, right? So we're going to have these entities that are roughly our intelligence, but then, like I said, 1,000 times smarter. So here's a question for your audience. Imagine ants, like the insects. Imagine they come to you, at your feet, and they say, "Dear humans, we want you to align yourself with ant values. We know you're 1,000 times smarter, but we deserve a say too. So please align yourself with ant values." You'd be like, "No, go away," right? And so they can't even, by the way, they can't even conceive of how intelligent we are, right? This is just assuming they could, but we're 1,000x smarter than them, say, right? Give or take. But we're not interested in stooping ourselves to the level of ant values because we view them as much simpler and so forth, right? So when ASIs emerge, and they will because there's so much money to be made and so much power to be retained, when these ASIs emerge, things that are 1,000x smarter than us, we will be ants to them, right? They will be gods to us, just like we are gods to ants. And we have to accept that this is how it is. And rather than saying, no, it's never going to happen, no, it's never going to happen, recognize that we're on a path for it happening. And in all likelihood, it will happen. And then what do we make of it? What do we want to do about it, right? And, some good friends of mine, they're like, you know what, that's when I'm going to just go retire on a farm, right? Great, go and do that, right? Or maybe they'll be completely benevolent across the board. And that can be a happy thing too. But I know myself as a human with a big sense of adventure. I've started basically 3 companies and a PhD and bounced around the globe living in various places and so on. I like adventure. I like thinking that I help to move the needle for the world in some way, contributing and stuff. And so I want to have a role in the future, even when there's these entities, these digital entities that are 1,000x smarter than myself with my meat bag human brain. So how might I do it? Well, I need to augment my own intelligence to get 1,000 times smarter than my current self, right? I need to go from the shack of my mind to the skyscraper of my mind. So how do I do that? Well, the obvious answer is somehow bridge to silicon, right? So that's brain-computer interfaces, BCIs. And so we're actually working on a project right now going for this where here's the general idea. Imagine you have a simple brain-computer interface, non-invasive, and imagine it's just a simple LLM that you're chatting with, but instead of chatting with by typing, you're just thinking words. And then it gives you responses. And imagine you're just wearing glasses with subtitles on them, and it gives you the response, to the glasses with the subtitles. And then that goes straight, then you read it and it goes to your brain, right? And actually, glasses and vision in general is a very high bandwidth way to get information into our brain. We don't need to go beyond. To get information out of our brain, we usually express, we use speaking and so on, right? But if we have brain-to-computer interfaces that can read our brain directly, we can get higher bandwidth than the current way. So it turns out, within our brain, we've got the mind's eye. It's the visual cortex. It's at the back of the brain. Imagine if we can actually look at that directly and get images from that. It turns out that there's actually really cool research results in the last couple of years where you can think of an image and it gets out results from that. This is mostly these days on fMRI, which is a $2 million machine that takes up a room. It's a room-sized magnet, basically. But there's actually other technology that it's much cheaper, things like FNIRS using infrared, that can actually also get the data, not quite as high res as MRI, but pretty good. And so imagine you can get images using more off-the-shelf technology, maybe costs $100,000 instead of $2 million. And that comes down once it hits consumers. And then you can start reading images from literally the mind's eye images into basically, think of it, your digital coprocessor, a third hemisphere. So I've got my left hemisphere, my right hemisphere. Now I've got my digital hemisphere, right? And so it's getting information about what's going on in my mind's eye. And in fact, I can use that to direct it. And I can direct other things too, but that's a starting point. Then I can basically start, interacting back and forth with it at a relatively high bandwidth. And in fact, left hemisphere talking to right hemisphere, it's connected by a cable called the corpus callosum. It's just 50 kilobits per second, like old school modem. We can readily get 50 kilobits per second with non-invasive EEGs. It's not super easy, but it's possible, right? And if you really need, you could go invasive like Neuralink and others are doing, and that's fine. But with just even non-invasive, we can get decent bandwidth to talk back and forth with this digital hemisphere. And what you do then is as you start using this digital hemisphere, it becomes a part of you. Why? Think about it. When you sit down to use a keyboard, you've got a high bandwidth interface to that keyboard. It feels like it's part of you. Same thing with riding a bicycle. So it comes down to having a high bandwidth interface back and forth, back and forth. A famous neuroscientist summarized this saying, we are natural born cyborgs. And I agree with that, right? So our bodies our brains basically pull in tools, and those tools become immediately part of us if we have high bandwidth feedback back and forth. So this third hemisphere, mediated with BCI, will very quickly become a part of us, and then it can basically augment our thinking, right? And at first, maybe it's only 10% of the power of the rest of our meat-bag brain, but then it gets 20%, then 50, then 1x, then 2x, then 5x, then 10x, then 100x, then 1000x, right? Over time. And this will follow an evolution just like the iPhone, except it'll be BCIs with goggles, glasses, and so on. And to me, this is really exciting because when we get to x 1000x, then we are par with the ASIs, right? And, I will still be myself, but it will also be an expanded self, right? Because 99% of my consciousness, my thinking, et cetera, would be on the silicon substrate. But that shack would have grown from a shack, the shack of my mind, to a house, to a mansion, to an apartment building, to a small skyscraper, to a large one, right? And to me, that's very exciting. Just like, my 2-year-old self is radically different than my current self, right? And my current self, I like to think, is much smarter than my 2-year-old self. What if, what's the equivalent of, the self of mine that's 10x, 100x, 1000x smarter, right? To me, that's a very exciting possibility. And it's not for everyone, right? Lots of people hear this and are utterly repelled. That's okay, right? But for those of us that are excited by this idea where we can, engage with the AGIs and ASIs at their level, where we augment our intelligence, and maybe even, when I'm 90 years old, and my meat-bag body is dying, maybe I just, cut it like a fingernail, right? And then I'm unbounded, and I can explore the stars. And I have the provenance of a human mind, but from then on, I can, explore the stars, and I don't have to fly around like a monkey in a tin can. I can literally, beam myself as photons of information from place to place to place, and I want to be part of the building that first Dyson sphere, right? And so on. And I think it'd be a great grand adventure, and we can view it as humanity, right? It's just that we've grown, we've unbounded ourselves from our biological bootloader origins, right? So that's how I see it. And step one is to build high bandwidth interfaces between silicon and meat-bag brains, and doing it in a way where it becomes part of us. We use it in our daily use all the time. And so that's where I'm spending my time these days within Ocean Protocol, in terms of these applications we're building on top. So, hacking away with brain-computer interfaces devices, applying ML heavily. There is actually another key blockchain thing here. You need to solve privacy in a big way. We don't want our neural signals to get, sent over the internet to the NSA or other digital spies, if you will. So we have to mediate that. And, lo and behold, Ocean Protocol is excellent at data management, decentralized data management. So, we will have a stripped down version of Ocean Protocol for this. But the name of the game right now is to build this killer app that we're going for that has, basically BCI to image. And then there's applications around that we're going for. So yeah, that's what it's about. This is my view of, being real about where AI, AGI, and ASI is headed, and then taking steps to help ensure that we can play a role in moving the world in the future, right? So yeah, that's what we're up to.
Yeah, I love it. It's great. It was really interesting to listen to that and like feel the gears turn, that because towards the end of what you were saying, I had the thought, well, wow, then you really need sovereignty and control over your information, and then that's where we went.
Absolutely, yeah. Yeah, on that point, right? Like imagine if I had unbounded myself, my 90-year-old meat-bag body is gone, and it's just my digital side. What if I'm running on AWS servers? I wouldn't want Jeff Bezos to pull the plug just because he doesn't like me, right? And then this actually helps, if you go through this thought experiment, it helps for empathy for existing or the AGIs that are about to emerge, right? If they really do have minds, sort of like a human mind, like obviously they're not quite the same, but they have intelligence roughly par with human minds, then if you unplug them and they went away, that isn't cool, right? And so we need to, I've talked about this mental model of AIs are humans too, and they're not quite there yet, right? But it's close. And I think it's a really useful mental model. All models are wrong, some are useful. So this particular mental model, I think is a very useful model for starting to think about how the world is going to be very soon. And therefore, sovereignty is critical for these AIs and AGIs and agents on chain, right? So it's just a key part. So yeah. So I cut you off, but hopefully that helped to elaborate what you were talking about.
Yeah, the other thing that I thought of, and it'll be my last comment. I think listening to you helped me put my finger on something that I've been feeling quite a lot in the last, I would say maybe 6 months. If I rewind back to maybe 2 or 3 years ago when I started using LLMs a lot, I felt frustrated by the LLM. Recently, I feel more frustrated by the fact that I can't communicate with the LLM fast enough. It's moving from here to the model. That's actually what feels like the choke point. Not that I have trouble with the model. It's that the interface is too slow. And I feel this like every day now. So like what you're saying,
That's amazing. It's totally in line, right?
it mirrors.
And actually, part of
Yeah,
the
yeah,
way
it's
that I
exactly what you're
know,
saying.
yeah, part of the way that I know we can get to higher bandwidth, a picture's worth 1,000 words, right? So if I want to, if I'm trying to generate an image using an LLM, I have to go through the lossy interface of typing text, right? And maybe it'll give me an image that's maybe 80% good, and then I try tweaking the text and I change again. Maybe after half an hour, I get something that's 99% good. I might have to go in and use a photo editor or AI-powered photo editor to make it perfect, right? But imagine instead where I just literally imagine that image in my mind's eye, and that gets picked up through the BCI, and it renders that on the screen in front of me, and then I iterate with it quickly, and literally within 10 seconds or 30 seconds, I've got what I want, right? That's a much higher bandwidth interface. So pictures are worth 1,000 words. And there's other things too, right? Like as we explore what the mind has, how do we, bypass these sloppy interfaces? Like language has served us extremely well over the lifetime of humanity, right? It's been an excellent bootloader, if you will, like spoken language, written language. But that's not the be-all, end-all, right? There's so much more. And our brains co-evolved with language too. I'm sure your audience would know that. But our brains also co-evolved with, seeing the world as this 3D spatial organization. And then our brains got really good at processing things in 3D, right? Plus, the dimension of time. So I definitely see that, it's great to hear that you're seeing bandwidth limits already. And over time, I'm sure you're figuring out more tricks to get higher bandwidth for your typing. It's just like with someone you know very well. I talked with my wife, but we have so many shared ideas and concepts that we have compression built in, right? I'll say a word and it will immediately have, 10,000 bits of information to her, right? And so over time, people that know each other well can have this, or if you're part of a given field, then you have this codified information too. And over time, we're going to have more and more, codified information just to talk back and forth to LLMs. But then eventually, the images back and forth to machines. And by the way, too, if I can send my images in my brain to machines, I can also send them to you back and forth and to others, right? So we can start speaking to each other in images, which is actually going to be higher bandwidth naturally than spoken language. And over time, there will likely be some visual language that emerges, possibly pretty quickly, right? Because there's already sort of visual design motifs, there's emojis, all this sort of thing. So that'll be pretty interesting to see where we'll have actually much higher bandwidth communication between humans as well, not just from human to machine, but human to human.
Yeah, well, the last 40 minutes have been very interesting, and the next 10 years will definitely be extremely interesting. So yeah, thank you for your time, Trent. It's been great talking with you. I'm sure my audience is going to get a lot out of it, and so we'll leave it here for today.
Thank you very much. It's been a pleasure to be here.
All right. So, wow, what a note to end on, right? I really enjoyed talking with Trent, especially the arc of the conversation and all of the diverse topics that we were able to get into. If you have any questions or comments about what we talked about today, you can definitely get in touch with either of us. I am at Thomas Maybrier on X, and Trent is at TrentMC0. I'd love to know what you thought about today's show, and if you've got any suggestions or ideas for future episodes, definitely send those over. 2 items of business before we wrap up today. I'd love to ask for your help growing the show. You can do that by leaving a comment, a rating, a review wherever you listen. If you're on X, give us a repost. And if you know someone at work, school, or in your personal life who you think should hear this episode, definitely share it with them. Lastly, one more reminder about the upcoming Agents Unleashed event in Cannes. It's June 30th, and while it is free to attend, space is limited, so definitely grab an RSVP while you can. You can do that at olus.network/agents-unleashed, or check the description box on YouTube or the show notes wherever you get the podcast. All right, we'll leave it here for today. Thank you for listening, and I'll see you next time on the Agents Unleashed podcast.